Welcome everyone to our operating system design series. Of course, in my case for microkernel, although we are here with T2 running, me personally and such others, 20 years Linux, and with 20 years of rolling your own distribution, certainly I'm allowed to question some development. So what is new here is from veteran Linux developers here from Linux Foundation, no less, a proposal for a new system call. System calls, for you who might be new in OS stuff, system call is when a program like your shell or Firefox wants something from the kernel, like open a file, then that's a system call, open a file. It is so simple, or read, write, read to a file, write to a file, get directory listings and network sockets and stuff. So all of this, Linux has hundreds of system calls, maybe 500 or something, doesn't really matter much. Microkernels sometimes it's less, but so it doesn't really matter too much, although some system calls are super specific, like do crazy specific stuff, like even for KVM virtualization, do some address space management and IRQ virtualization and stuff. Anyway, so here proposal for a new system call, in my opinion rather silly, but anyway, let's discuss. So Greg Hartman here proposes a tiny monolithic kernel, millions of code, tiny little 501 or something system call, read file. You might wondering, what the heck, could we not read files before? But that makes it simpler to read small, medium-sized files all in one shot. No need to do open, read, close, just what I said before. And this is especially helpful for tools that poke around in procfs or sysfs, making a little bit, high performance applications like your database, your file server, your network application, poking around a lot in sysfs and procfs. Okay, these 4 patch series, so here touching here all the architectures, obviously adding there some system call, like our lovely MIPS N64 and Spark stuff, previous videos. So some people, of course, question here, like maybe if I understand this correctly, like 3 don't bother with the entire thing until somebody manages to demonstrate a setup where it does make a real difference compared to the obvious sequence of syscalls, that is, which at which point you'll need to figure out what's going on, deal with underlying problems in the setup. Anyway, maybe I understand this wrong, maybe not, but in my opinion rather pointless, because a very specific thing that you need for next to nothing except CPU virtualization stuff, like such kind of neat little widgets and top and stuff, and other GNOME applets for your fan and temperature. Anyway, so let me explain. So what would I propose if you all say, hey, you only criticize stuff, but 20 years of experience and I can't see the stuff anymore. A little bit. Okay, let's propose something better. I think I proposed this in my microkernel stuff. So what we're talking about, what I thought I commented this on my blog, didn't really find it. I thought maybe I'd take a look on another day, but I for sure mentioned this a year or two ago in my microkernel design stuff. So what we're talking about, we're talking about in file descriptor open. That's a system call hidden behind a C library wrapper, like sysproc, like PID, whatever. Top might read there 1,000 times, read, close. So so what does it save? It saves us like 2 system calls. Out of 3 system calls, we get 1. The new proposed being read file. Can also copy this for that, and then that would be like buffer size of buffer, whatever, you get the idea. Not caring, and obviously error handling rights and return value of whatever. So YOLO, whatever, super boring. So let me explain what I would propose instead. So the regular system call stuff is all like system call on 386, by the way. This was a software interrupt. Usually on 386 this was 80 hex, until Intel and AMD had a higher performance syscall instruction for doing this a little bit more elegant instead of a software interrupt. On other architectures, previous video instructions at architecture, Spark, RISC-V, MIPS and so on, you usually have a system call instruction since forever. On RISC-V, I think probably is eCall. So what I propose instead is a vectored system call. I proposed this already a decade ago, but yeah, I think in the meantime someone commented on the YouTube comments of the previous microkernel videos, which you probably might want to watch, that there were research papers. So obviously, as so often you see software patents, I'm not the only clever or not clever person coming up with this. So what I proposed already years ago, and allegedly there are research papers, is syscall v, vectored system call. The implementation details might vary. How this would look, so for my design in our soon to be written and started in high performance microkernel, this would be natively supported, right? So in my design, you could like vector like one message passing block of whatever system calls. This might be open, read, close. It might be something else. And actually, you might be surprised to learn that Unix POSIX systems have something like this for quite some time. Read V and write V. Many people. I recently asked a veteran, a highly profiled programmer friend of mine, by the way, have you heard about read V and write V? And he was like, huh, what? Like, yeah, so much to highest level veteran programmers like read, write, whatever. Anyway, so what is that? That is this, and read and write into multiple buffers. That is something sort of similar as instead of having multiple read and write system calls, this already allows exactly that, vectored as instead of a handful of n, having this in this IO vector array here for, and similar to this, you could handle this, again, I said, not talking in implementation detail, so you could handle my vectored IO, vectored system call proposal in pointer to a system call. This could be implementation details. It might be something like each system call message passing block has like 64 bytes, or for example, you would have here some system call n, for example, and some pointer. But again, can we also probably make this larger for you probably to play along at home. As implementation details, you could go there crazy. You could also, for example, and you could also have this structure brainstorming here some ideas. You could also have this like bytes, so that each of these message blocks, instead of having this fixed 64 bytes or something for each system call, having here n bytes, like variable length system calls, so that you would have here n bytes for the first, but doesn't really matter, and then n bytes for the second, and so on. Doesn't really matter too much. You could go there crazy. One tiny little detail would be, so in my proposal, I set this in the original microkernel design stuff, and yes, we will for sure implement something like this sometime soon here, live on this channel. And for our own upcoming tiny little hobby, will not be as big as Linux microkernel stuff, because I'm tired of old-fashioned systems. So there are two issues with this. So one thing is, what do you do if one of those system calls fails? Because, you know, errors happen and you always need to check your return values. I would propose, because you might not want to do the other stuff. So for example, you might also have, instead of this open, read, close sequence, you might have like having this flexible and having a solution for this vectored read write. You might have here read multiple times read, or write, doesn't really matter much, right? You probably get the idea. And for this, you might not want to do the other stuff if it fails. And also with my stuff, with my proposal, again, probably I need to check my blog if it hopefully documented this a decade ago. Not only is my proposal more flexible, see, you can do system call, like vectored system call, open, read, close sequence for this high performance system activity and top stuff here, right? Or like vectored read, write stuff. And probably not really sure, you need to check the man page, if this IO vect, so probably this write, vectored read and vectored write probably can only do this in one file descriptor. My stuff would allow the flexibility to do this for different file descriptors, but I might read this wrong, but I think that's probably how it is. So my stuff could even do this stuff like file descriptor 1 and file descriptor 2, and even mix this, right? Even do read and writes together. And two things. So the first thing is, what do you do with errors? So you could have a some kind of flex here, like wherever, doesn't really matter much. Maybe the first for together with the size, maybe. So the first could be size. Again, just brainstorming, don't need to implement this. So it could be size and the high order bits, because you certainly don't need a 32-bit size. So the size of the system call structure, again, maybe like depending on the system call, also it could like variable length depending on the system call, read, write, select, and so on, fork, and kill and whatnot, and alarm and so on. And so this would be like variable length depending on the system call, and you could have here additional flex. So this could be like stop on error, for example. Like by default it continues, and you get the kernel will fill out the return values here in either overwriting this, doesn't really, again, brainstorming, implementation details, doesn't really matter how you do this. There are possibilities are usually endless. So like stop on error or not or whatever. And that would be the one thing. Like what do you do on errors? Like stop or not, like execute them all, even if it doesn't really matter much. And the second, and again, there are solutions for this, right? Just make there some flex, continue on error or not, whatever the case might be. And the second thing is for, there are some comments, but let's take a look in the second to have this, keep this a little bit sorted, and take a look there just in a moment. The second thing is for this special case, you don't have like this open read close sequence, you don't have the return value of the first open system call. So for this, because for read and write you would need here this fd equals the return value of this vector system call. So my solution for that would be use the same flex. Like you can't do everything because you certainly don't want to have hyper complexity of going crazy there, of like the Linux kernel of programmable Berkeley packet filter just-in-time compilation stuff, but allow there some tiny little combinations, like the most common stuff. Usually you don't need this, only for this kind of open read close stuff. So second thing is like use the return value. Let's do this here. So that would be n. Like use the return value of the previous system call as an argument, like the first argument. So this would be here like n stop on error, and here it doesn't. Here probably, if for example, if this read, like the read fails because it's a short read, although a short read doesn't fail, but whatever, if the read fails or whatever reason, so you can open, you want to open read close, and this open fails, then yeah, you can stop. You don't need to try read and close on a non-existing file handle, certainly. So here you don't need this flag, because in my proposal we would already return your stop on error, but if read fails you would still want to close, so that should still run. And the second thing is either here or in the other, doesn't really matter much, like arg1 read, like return, like return value, return value from return previous arg1 or something, like a few little flags, so that for this special case I think you probably would need this rather often. Again, not going crazy, not going full BPF, Berkeley packet filter, just-in-time stuff, things that is certainly not wanted complexity here, but like this tiny little stuff like return previous arg. Again, if it's an error, we fail. If it's not an error, return value of previous to arg1 here for reading this buffer. And in my opinion, this would be so much more amazing solution, would get rid of read vectored stuff and tons of other stuff. And again, I proposed this. This idea is not new. You I don't make this stuff up. This was already my solution for how to improve. Initially, this was my solution to how to drastically improve performance on microkernel systems where you have much more system calls going from user space applications through your kernel to other file system and network servers. And this is exactly what I proposed already for that. And certainly that would be a much more amazing, flexible, high performance, drastically more useful also for high performance databases and file servers and other high performance applications. And even audio application, like basically everything, graphic applications, your graphics stack, yeah, whatever. One other thing I think I wanted to mention, what was that? In terms of, another thing that allows this for, you have seen in my previous video where I was implementing in our sandbox file list wrapping technique, the support for the various new Linux kernel IOCTLs, like we even had rename at that we were missing for tar actually archiving some of our files, but much more often used OpenAt, which I already implemented a couple of years ago. And this is also like my veteran senior programmer friend, have you ever heard about this? It's like, what? It's like, yeah, normal like high performance application database and other fun stuff. People don't care about this kind of modern system call variations. So what this does is, instead of normal open, where you open either absolute path name or relative to your current working directory, which does not scale because in highly threaded applications, your threads might all want to have another reference as to current working directory, think high performance Samba file servers. So this is extending the classic open system call to a directory relative flag here, like open relative to this previous directory file descriptor. So all your threads and contexts can have like Samba file server. One user has your local file share invoices, the other has your local file share text statements or marketing material, and or our YouTube editing department, their YouTube project X, Y, Z, and so on. And actually you could extend this, instead of introducing a new open system call, you could use this length encoding, like a good old-fashioned open would be, let's say we would have, what is open? It's 3 open, or, okay, that is some stupid per. So path name flag, so a regular would be like maybe a length of a pointer, so that might be 64 bits is 4 bytes, 4 bytes, 8 bytes, plus, so like maybe a classic open might be 16 bytes long, and you could even add here optional flags, and instead of introducing a new system call, extend this with, hey, this open stuff is using some system call format of 24 or 32 bytes or something. So basically you could have here optional arguments and new versions. And if your kernel doesn't support this, similar to Linux, if you system call OpenAt, you will get some error return, probably E not implemented or something. You can actually look up not only user include, that would probably be either generic or, of course, not generic, syscall. Let's see, do we have that and syscall here in vsyscall? What? Yeah, and at least some UniSTD, whatever do we have here? Okay, ISM, okay, fine. Amazing stuff. So yeah, the system calls like read, write, I personally, yeah, the number chosen, I personally would start with open, but yeah, Linux kernel starts with read. The wonders of backward compatibility of whatever, logically I would find this, obviously the numbers don't matter at all, but these are the freaking system calls, get priority, set priority, and all the fun stuff. And I guesstimated 500, we are at 322 here at least, plus minus whatever. and open@, is 257. And if you issue a like run, as in calling a system call with a system call number in a kernel that did not implement this, you certainly get something back like, what would this be? Error no of course it is ASM generic only live on this channel, looking up this stuff. So that would something that not supported, or not socket, no, either. Also this starts, I don't know, base, can't make this stuff up. Base, obviously. So this would be not supported. What would be, whatever, something of that sort are implemented probably. Oh, come on. Grab E, implemented, no. Anyway, whatever the most matching system call. Also, I'm probably in the wrong directory. Let's do that for that. Grab EE. Not notify, but maybe error. Function not implemented, so maybe E no sys. Maybe also, so there's something supported, but maybe not. But you get the idea. So you could do this similar here if your kernel doesn't support a longer variant of that without adding even more system calls, because certainly open and open@, are rather similar to rename and rename it, and link and link@, whatever. Link@, I guess, yeah. Link@, it is. Anyway, that's my my 2 cents to that. This vectored system calls were previously not. I think it might have been discussed or something some time ago. Maybe a lot of things were previously discussed, but yeah, this is innovation in Linux, adding a read file system call, maybe potentially in 2020. One other thing, and then we take a look at the comments. What was the name? Even new system call readfile. One last thing. Did I hopefully save this or not? One last thing is one implementation detail. I thought actually, here I saved it. One last thing is that if you have, like, theoretically your evil like tar bomb, like DOS, denial of service application, could submit here like 500 or something system calls. First of all, this buffer certainly would be limited to 1 page size or something, so maybe 4K or something. Secondly, this one implementation detail should be for a really well-designed kernel implementing this vectored system calls, that this is subject to regular scheduling. So because the kernel is running potentially hundreds, also usually only like maybe 4, 5, 6, 7, 8, 9, 10, 16, something reasonable. But if a evil DOS application, DOS as in denial of service, not in disk operating system or quick and dirty operating system. If your denial of service application is running, submitting 512 system calls, they should be, and this evil application could do so, like bombarding the kernel with time-wasting system calls already today. The only change is now it can bundle them with this in bundles of large bundles. So they should be, like, handling the system calls in your kernel should be subject to regular scheduling, so that the execution time on behalf of this application, like Firefox issuing 16 system calls here, vectored system calls, that if they take long for whatsoever reason, like reading and writing 4 GB of data or something crazy like that, it's subject to regular scheduling, so that one evil application cannot steal all your 32 or 128 threads of these epic thread ripping days. But anyway, you get the idea. That probably are all the corner cases of this kind of design. and some outline of what kind of details you need to think about, whether you design your monolithic or microkernel, your hobby or not hobby, your non-real-time or real-time OS. I hope you learned something. Let's quickly go to over the comments. And if you are interested in even more stuff, I theoretically have we could do a fun little MIP64 Octane live stream on the More Life channel. If you are new to this channel, there is a More Life random live channel there in probably, let me think, this corner, I guess, to subscribe. And theoretically, maybe we go live after this live stream for a little bit of MIP64 SJ Octane hacking here live on these channels. Let's see what we got commented here. Actually, into the batch video call stuff, never get latency down on my bare bones. So Anduin actually tried this apparently and never could got the latency down on his bare bone non-UEFI OS apparently. Fun stuff. Happy to hear that you tried this. If you have, as usual, if you have any comments, also if you watch this later in the archive section, even in a week or year to come, always leave your thoughts and comments there below. Ian writes, reminds someone Windows NT DDI syscall batching calls were unlikely to fail, but required the kernel transition would be queued into a thread. Yeah, also for my, this is exactly what I had in mind for having a UI server with all the fun little low-level 3D acceleration videos here, previously from Verge, Voodoo to Link 3D and stuff. We will certainly continue with this, also certainly for our multi-server operating system. And what I was thinking is to have some GL-like API over something like vectored system calls, or like this Linux kernel high performance, this newly added high performance asynchronous IO rings. That would be fun little features. Probably very few people know about Linux UI ring something. Also best with what typos. What would this be? Something totally new as in that was just added in 2019, I think. Something of 2019 January, a couple of years ago. So they certainly do some innovation stuff, and you see they do not shy away from complex high performance stuff. And something of that sort, some kind of ring structure. And this is also certainly how you highly hyper threaded, like since this new epic thread wrapping stuff here, 32, 128 threads, maybe some like thread U-ring stuff might be a much more high performant way to do really high performance system calls, especially in the days of Spectre and Meltdown. Certainly I probably, a pity that I'm not a professor at some university. All the fun stuff you could actually research. Probably I should document this on my blog next. High performance U-ring user space kernel ring system call queuing. Maybe that would be amazing, certainly something to research and take a look another day. But certainly something of this sort I would do for generic GL or Vulkan-like API scheduling from user space to a Windows server without the complexity, because in my opinion it is easier to write some user mode kernel, user mode graphic driver in user mode with some generic GL or Vulkan kind of threaded ring call interface, context switching stuff, than the Linux setup of application direct rendering interfacing to the kernel with a windowing aka Xorg server with some stuff in the monolithic kernel. Anyway, crazy setup. Probably there are generic yet high performance ways to structure this in a much more readable generic way. When its full system call is made and not batch, the batch would be flashed with a system call trap handler, dual buffer on the calls, and it would error handle if lang didn't match on iteration or something. Anduin didn't know about GDI batching. Yeah, I also didn't know that kind of details, this kind of Windows details, but are hard to come by, and certainly I ignored Windows for the most part of the last 20 years anyway. But yeah, closed source OS less fun to research. Ian writes, Yuan did a good write-up on his GDI book. Iron out a lot of security bugs in the processors. The batch, but the code was written in the 90s before for security mind, and writing this code. System calls more like you make system calls more complex. Naturally, there's a price to pay in the something batch security. Yeah, welcome everyone. Welcome Marco. Welcome everyone. Glaucus is also in supporting the need of a microkernel series. Definitely, Cisco priority makes worry about ordering and app syscall priority. So I'm not proposing priority. I'm proposing to handling this is serially, so submitting a vectored batch and handling them here, iterating over them one at a time. Anduin writes, if it would be applied to system kernels, then any implementation would be able to short circuit to other system calls. Had to do it when batch calls would have a loop in the middle, switch you back to the user space context, essentially negating some benefits. Welcome everyone. Is the machine running like you want? What do you mean with that? Ring IO batch all the way. Anyway, yeah, so that are my 2 cents from my side, but yeah, innovation in the Linux, monolithic, and yeah, but this is also previous video. If you're new to this channel, we regularly do this and other product and this kind of design theories here, stuff that in my opinion is a little bit neglected, and many people only praise this stuff like on some major news sites, like, hey, some high performance read file is coming. It's like, no, for what? For that your top end, your geekram or my system thing is more high performance, like, nah. Besides, you also need some libc wrapper, and it's like, yeah. Anyway, I would rather, a previous video did Linux kill all operating system, or not all. Certainly I titled all, but most operating system research, because everyone in his basement, bunker and garage is only doing Linux distribution like ourselves for 20 years, and not like doing new high performance, more readable, more secure, more like verified or verifiable, safe language, Rust, other, you name it. Anyway, that's it for this. Maybe I see you back in this More Life channel with the SG Octane. Otherwise, I hope you learned something. Again, as usual, leave in the comments below what you think about this stuff. And otherwise, I hope to see you soon for all the next videos and live streams to come.